I repeat, we will just check memory organization today, and then we'll move on with assembly and C programming. So how your programming is gonna move is that I will start with the basic codes, okay, basic statements. I'll explain you how it is done in assembly, in contrast with the C version of the same code, and we're gonna execute that code. We are gonna see how it is reflecting in the memory, okay, and we're gonna suppose the code is of let's say LED blinking. We are having LED blinking wala code at some output port. Then I'll show you on one of the simulation software how it is looking. Okay, I'm still arranging that software on this machine. Okay, right now I'm not really home, so yeah, but yeah, I'll try to arrange it here as well. So this is how it is gonna be. So it's going to be more interesting from tomorrow onwards. Anyway, so let's start. And the content I provided, the PPT, actually your TA1 was supposed to be like whatever I covered, okay? And what we have covered so far is unit one completely, and half of the second unit. But you will find only one PPT on that because I've not separated it yet. There are a few changes that I got to make, and post that it will be sorted. But yeah, the content is gonna be the same anyways. So before we begin, I would like to ask you guys if you are aware of hexadecimal number systems, base 16.
Yes, sir.
Yes.
Okay, so do you know right how it goes like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Is it 10
Zero,
or what?
0 to
Yes, sir.
9 and
It's A to F, 0 to
A
9 and
to
A
F,
to F.
right? 10 is A. Okay, so A, B, C, D, E, F, and then 10, 11, 13, 14, 17, 18, 19. Hmm?
it is still 15 only, I think.
Sir, till F only.
Still F.
Till F. After F, what? Like C.
It goes
I'll
into
tell
combination.
you. Will there be only 16 numbers? No, right? This is a number system, right? It has to go on further beyond that, right? It doesn't stop at F. Okay, it is till F only. Okay, after F, what starts? I'm gonna tell you.
Okay.
So after F, there is 10. Okay, F is treated as 9 over there in hexadecimal system. Like it is hexadecimal, right? Base 16. Our normal number system is decimal number system, means base 10. This is base 16. So till 16, and after 16 comes 10. Okay, after 16 comes 10, then 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, and now it will be what? 1F. Okay, okay, I'll show you. Wait, I knew you will be confused here, so I have one document that will show you what I mean. I'll share that window specifically. You see my screen?
Yes, sir.
So see here you you have 0 to 9, right? Similarly, you have 10 to 19, and after that 1A, 1B, 1C, 1D, 1E, 1F. Okay. Then we have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 28, 2B, 2C, 2D, 2E, 2F, and 30. Are you understanding?
Yes, sir.
Okay. 0 to 9 and A to F is getting repeated in sequence.
Correct. Correct. So basically 0 to 9 you will treat normally, okay? Post F, okay? But post F that will happen. Okay, means your 10 is your basically your 16 now, something on the similar lines, or 15 because it is from 0. If it was from 1 then it would be 16, but 0 to 15, okay, that is hexadecimal. Okay, so hex 16. Okay, so 0 to 15 means is your basically 0 to 10. Your 0 is 0, F is 10 or 9. Okay, then again 10, 11, 12, 13, 14. After 9 again A, B, C, D, E, F. Then again 0. Okay, then 2, 0 to 1. So it goes like this. So why I'm describing this to you today is because I want you to know this, as we're going to learn memory organization and we are going to be looking at the memory locations. Okay, as and how you go on further into embedded systems, you will come across such locations like uh, clear clear E to H, clear DC, clear DA, clear CC. So you should know which location I'm talking about, or which location you got to work on. So, however, you may not be addressing, this directly. Like there are addressing modes, but you will not always do that. I mean, as far as your knowledge is concerned, I'm not gonna be focusing more on that part because this is, you know very selective area of work wherein we are specifically working on memory. So so when does this location actually matter is, suppose you are working with external memory, so you know that our controller has limited uh, data and program memory, right? So data and program. So program memories are ROM, and that is what we are more interested in because that is where our program is stored, right? So suppose that is not enough internally, offered is 4 KB, and your hex file is exceeding that. So what will you do? You will have some external memory interface, right? And in that case, mostly you will need to access the memory locations precisely, and that is whole another theory how to access external memory. We have this EA bar pin. If you select that 0 or 1, what happens? We're going to see that today, which memory locations are being considered. So this is what it is. So so moving forward. Yeah, so is are rest of the students joining, or like did you have any were like any communication with them and see if they were interested joining?
Sir, Shubham was in the lobby, but I think he was getting some problem while joining.
Oh, okay, okay. Give me a moment. So I'll share my screen now. We'll get started. So meanwhile, would any one of you would like to, share how power on reset works and what exactly happens? How does our controller know where to start executing the code from? Uh, like, what is that basically? So, my question is, like we discussed the last time, when we said when we press the reset का button, okay, तो वो button press करने के बाद what all happens inside of this little chip? That is my question. Hey, first of all, do you see when I hit this slideshow? Do you see full screen mode, or you still see the compact window?
The compact one. It's not the.
Okay, yeah, this is the problem with window share option. I need to share my entire screen for that. Okay, anyway, so I'll share it. Now, what do you see?
Yes, sir.
Is
Okay,
it complete?
thank you. So, so there is a reset somewhere, and there is ground somewhere. There is VCC somewhere. Okay, all these pins work together to uh, you know complete the circuit, and so this is VCC. This. Then we have reset. So I was talking about this pin. Okay. So what happens exactly? We have discussed this in last lecture. I'll just give you a quick revision so that you don't miss out on it. Basic functionality of our controllers. Okay, because this is going to be very important going forward, as you will be making this circuit in the simulation software, and if anything is going wrong in it, you should be able to understand what is going wrong. And until unless you don't understand what is this about, you will not be able to crack it further. So yeah, reset. So reset is basically how it works is we have suppose we give VCC, we connect reset to VCC, or we give pulse to this reset pin. What happens is that our controller goes into power on reset modes, means all the status, all the RAM locations, and all the pins of the controller are gonna be in reset mode, means they will be in their default state. Okay, the fresh state when there is nothing happening. Okay, it will not be any limbo state. Reset is basically you start from beginning, start from scratch. Whatever is the code, run it from starting, run it from the beginning. So how it works. So suppose, and this scenario is similar to when we power on our controller for the very first time to run the code which is present in our program memory. So when the reset is hit, what happens is that there is one startup code that runs in the beginning. And what is that startup code or startup files? So these startup files are provided by our IDE, or okay, or whatever is the software we are gonna code our controller with. So this software has the startup routine saved in it, okay, depending on the model of the controller you're using. So what does this startup file contain? So it basically has some step that our controller follows, okay, when the power on reset mode gets activated, okay. uh, those steps could be resetting, okay, initializing all the pins. It could be reading the variables, declaring some space for it in the memory. It could be anything. And one of the step which comes in the end is it calls the main function. And how does it know where the main function is? Okay, how does it know where the main function is? It looks in the program counter, and program counter has the location of the memory where our first function is going to be stored, okay. So this is how the flow is, and it goes there, it reads the first instruction, then again program counter is incremented based on the size of the instruction that was executed, so on and so forth, okay. Suppose instruction is of one, I mean, it increments the program counter by one location every time. And by one location, I mean the size of the instruction that got executed recently. So this is how it works. So so when you're simulating or any kind of code, this circuitry is mandatory. You should give VCC, you should ground it, you should connect what the crystal thing over here, oscillator over here, that circuitry, okay, that is mandatory. Otherwise, nothing will work, okay. Then this reset circuitry should be done properly. Then EA should be selected properly, okay. Most of the things nowadays are done by default, but some things are still mandatory to be done when we are simulating basically. So EA is basically some people call it external access, some people call it enable access. So it depends on controller basically. I have taken this very basic, okay. We are going to be looking at pick controller as well. So, and when I start about pick controller, you will understand that why I basically started with this, because you will be familiar with most of the features already when I start with pick. So that's why this particular controller. And yeah, so okay, anyways, we know all of this now. Okay, I will talk a little bit about the register banks, okay, or the registers, basically R0 to R7. R0 to R7. So basically, can you be quick and tell me what do you know about it so far? What have I told you about it so far? Like, why do we
Uh, s-
use a, yeah, please go
Sir,
ahead.
they are used for temporary storage of data
Temporary
registers.
storage, okay, right. But I want to hear about, is it only this much, like only R0 to R7, or there is more to it? Do you have any idea? Like, I'll tell you now, okay, anyways. So R0 to R7. So consider R0 to R7 four times. Okay, R0 to R7 four times means there are four register banks in any controller. Okay, there are four register banks. Okay, bank 1 2 3 4 or 0 1 2 3. Okay, depending on controller. Some controller starts with 1, some starts with 0. So suppose our controller starts with register bank 1, 2, 3, and 4. So register bank 1 will have R0 to R7. Register bank 2 will have R0 to R7. Means each register bank is having R0 to R7. So are you understanding the extent of the count of the registers that we have here? Like we have so many number of registers to be used. Okay, at a time we can use only one of the bank. Okay, and how do we use one of it is there is a special function register called PSW. Okay, which is program status word. So first two bits of it will decide which register bank we are using. Okay, so that PSW is a 8-bit register. Okay. Okay. Sorry for the bad shapes. I don't have the pen today. Suppose this is PSW. Okay, which is of 8 bits. Now these may not be 8, but you have to assume these are 8. So the first two bits are going to be deciding which register bank we are using. Okay, first two bits. Suppose it's 0 0, I'm selecting register bank 0. 0 1, I'm selecting register bank 1. Then 1 0 and 1 1. Are you understanding? 0 0 RB 0. 0 1 RB 1. 1 0 RB 2. And so on and so forth. Like, uh, did you understand this?
Sir, but
Yes, please,
in
sir.
one microcontroller only have one register bank.
One microcontroller has four register banks. Okay, and we select which one we want to use when. Okay,
Okay, sir.
so I will tell you the purpose of having all the banks separated, and because uh, we are definitely going to be looking at smaller sort of programs, but in practical application, okay, I'll try to get those codes as well. Okay, so what happens is there is some interrupt return. Okay, interrupt service routine return. Okay, there is some timer configuration done. There are so many things happening at the same time in the background. Okay, so we can dedicate every register bank for particular function. Okay, suppose I'm saying that I will use this first bank for only arithmetic calculation. I will use my second bank for timer calculations. I will use my third bank for interrupt. I will use my fourth bank for interrupt service routine. So I can have my algorithm decided in my head. Okay, and then I can write the code accordingly. Okay, suppose I am in need of selecting register bank 3 all of sudden. What I will do is I will store that value in this PSW register. Okay, I will say कि PSW में ये first 2 bits change करने हैं मतलब I will simply write this instruction called move. Okay, move PSW comma and whatever is the word that is forming after converting this value. Suppose uh, I said register bank 3, right? So 1 0 and the rest of the bits are 0 0 0 0 0. Okay, so what is this word? 1 0 0 0 0 means it will be if I'm not wrong, it will be 80h in hex. Okay, so I'll write move PSW comma 80h. So 80h value will be moved in PSW. What this 80h is storing, what it is, interpreting for microcontroller in terms of bits. 1 0 0 0 0 means and first two bits are 10, means it will by default select the register bank 3. This is how it is gonna be every time. Okay, if I want to switch the register bank, okay, suppose my application is basic, I will only go with any one of register bank, and that is fine with me. So these R0 to R7 four times, means register bank 0, 1, 2, and 3. So all these three banks or four banks, these four banks, then comes actual bit addressable memory. Then there are SFRs. So we'll go deeper into that as we learn the memory organization of RAM. Okay. So we are going to learn memory organization of RAM and ROM today. That's why I explained you this, because you should not get confused looking at that later on. So yeah. So yeah, we were just looking at this example earlier, that how the registers are used. So these will be used similar way. Okay, are you understanding? Suppose I am selecting register bank 1, no matter which register bank I'm using, no matter which register bank I'm using, it will be used the same way I'm using all the registers. Okay, they will be addressed R0 to R7 only. No naming convention will change. Okay, we are, because we are already selecting our register bank. Okay, we are already selecting our register bank before using that registers. That's why no naming convention will change. You will use it normally. Okay, no further programming changes. R3, R4. Okay, you looking at this, you won't know which register bank it is from, but the whole code will explain you that. Okay, and if there is some default configuration, I'll tell you that when coding. Okay, so this is how it is. Did you understand this? Do you have any doubts on this part?
Sir,
Please.
uh, when you showed the image of the microcontroller, so
Mhm.
it had only one register bank. This,
This one, or you talking about architecture?
no, sir, that one only.
Where do you see register
Sir,
bank here?
so
The
I
see,
thought so,
understand.
so that I thought that P things are register
No,
banks.
no, 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 no. Wait, I'll clear this. I'm glad you asked. So this is what pin configuration. Okay, this is how your controller will physically look. Okay, this is the IC. This is the chip. Okay, and these are the 40 pins. Okay, and these are ports. Okay, understand? These are ports, and those are register. Register is inside of this. Registers are inside of the memory. Okay, the registers are inside of the data memory. Okay, डेटा मेमोरी के अंदर है. डेटा मेमोरी अपनी कितनी भी होगी, ठीक है. आई एम नॉट कंसर्न विद द साइज ऑफ मेमोरी एट दिस पॉइंट. ओके,
Basically, registers are logical units. It's not a physical object.
लॉजिकल, या इट इज अ मेमोरी बेसिकली. ओके, सो नॉर्मली जब हम कंप्यूटिंग में बात करेंगे ना, वी आर लीस्ट बॉदर्ड अबाउट मेमोरी. ओके, बट इन इलेक्ट्रॉनिक्स, जब वी आर प्रोग्रामिंग फॉर सम हार्डवेयर, राइट, so memory location matters a lot. Okay, inside of the hardware. Okay, inside, suppose there is a washing machine, there is a microwave oven, there is any electron, there is an AC which has a PCB, which has controller, which has some this sort of coding done. So uh, suppose the VLSI chips. So memory location does matter. Okay, and that's why we are learning this. We are manipulating the data. Okay, and we are playing with the memory locations directly. When I say R0, it is targeting some memory location. When I say R1, it is targeting some memory location. Are you getting me? So these are basically pins. Okay, external pins. Okay, for input output purpose. Okay, input devices and output devices will be connected to these pins. Okay, this is not uh, you cannot compare it with registers. Okay, So basically, suppose there is some temperature sensor connected to this particular pin, okay, and it is giving you some analog value. So our controller has inbuilt analog to digital converter, and that digitally converted value, I'm storing it in one of the register. Okay, this could be an example. Converted value. Okay, if I want to compare two values going forward, so I have some baseline set. Okay, I take this value. Okay, I take the input of 7 a.m. का रीडिंग, 7 बजे का रीडिंग ले लिया मैंने, उसको डिजिटल में कन्वर्ट कर दिया, and I stored it in R0 and I kept it as is because I want to compare it with the reading of 10 a.m. Okay. So 10 a.m. का रीडिंग ले लिया मैंने, वो मैंने R1 में स्टोर किया कन्वर्ट करके. Now I can do any operations on it. Are you understanding the difference now?
Yes, sir. Yes, sir.
तो
Okay.
ये क्लियर हो गया ना? ऐसे ही
हाँ
कुछ
सर.
चीजें हो ना तो पूछो मुझे. ओके. सो ये ऐसे ऐसे चीजें हैं, मतलब इट्स जस्ट अ नॉर्मल एग्जांपल आई गेव यू. ओके, सपोज it could be more advanced thing as well, like this is port 1 and I'm taking it, I'm connecting, I'm using it as an input port. Okay, I have connected temperature sensor. Suppose my application wants me to have it displayed on a 7 segment display or an LCD screen. What I will do, I will use some other port as an output port. I will connect LCD screen here. Okay, we are gonna see LCD interfacing as well. Okay, interesting, very interesting bit. LCD display we are gonna connect here, and we are gonna be displaying the value that is being stored in the register. And but how to display? We will display it in decimal form, right? Of course, not in 0 1 format. Okay, so again that conversion will happen, and again that display will be there in okay, display conversion will happen, then we'll display the value. So this is how the pins are being used basically. Okay, and all the pins except port 1 all are multi-purpose if you see. Okay, so पोर्ट जीरो में तुम्हें AD0 AD7 दिख रहा है, पोर्ट 2 में AD15 AD8, ये मैंने ऑलरेडी एक्सप्लेन किया, बट अभी आ ही गए इस पॉइंट पे तो आई एम टेलिंग यू अगेन. सो इसमें क्या होता है, जब एक्सटर्नल मेमोरी हम कनेक्ट कर रहे हैं तो वी आर गोना बी यूजिंग एड्रेस 16 बिट का होता है, तो ये हमें एज ए एड्रेस वाले पिन्स यूज होंगे ये. ओके, एड्रेस कहाँ से पास होगा, इंटरनल टू एक्सटर्नल, इन पिन के थ्रू पास होगा. मतलब 0 to 7 bits port 0 will handle, and 8 to 15 port 2 will handle. So ये pins है and registers are different. Point that I was trying to make. ये DPTR प्रोग्राम काउंटर स्टैक पॉइंटर ने तो 2 3 सेशन ले लिए हैं ऑलरेडी, एंड इस सेशन में भी पहले का थोड़ा, एक मिनट. ओके, stack pointer. Okay, anyways, let's go for 10 minutes break. Okay, and we'll start fresh with the memory organization thing. Okay, a lot of numbers we are gonna play with now, so yeah, freshen up and come back. And most important, stay awake. Okay, let me know when you're back. I'm here. Hello guys, are you back?
Yes, sir.
Okay. So, so memory organization. I'll share my screen. Okay, meanwhile, program memory, data memory. Who is gonna explain? What is program memory? I mean, which is program memory, which data memory? What is exactly the difference? What is stored in what memory? Like, okay, I'll ask it this way. Which kind of memory I'm displaying right now on my screen? Which memory is this?
Program mem-
Yeah, it is program memory. You're right. So why would you say this is a program memory? Your answer is right, but why is this program memory? I mean, what made you think that this could be program memory?
It seems to be like a code memory, I think. It's just for
Yeah,
storing programs.
yeah. This is written clearly like internal ROM, right? So it is a program memory. What is data memory in contrast to this? Data memory is RAM. Okay, it is storing your temporary data. As long as power is there, it will retain the data. Okay, once the power is lost or power on reset is pressed, data is gone, vanished. Is this the case with this memory? No. This memory retains the data even in absence of power. Okay, you will see this in classification of memory. Okay, so it is basically, there are basically types of memory. Okay, there are electrically erasable and programmable sort of memories. Those sort of memories we use in controller as a ROM. Okay, that's why it retains the data. In order to erase the data, there is certain process that we need to follow. We need to erase the code existing in the memory and then we reprogram it. Okay, okay, this is about it. So now what do we see on my screen is there is some internal ROM and there is external program memory. You see this. Okay, so I already talked about EA bar pin. Okay, EA bar. You saw in the pin configuration there was EA bar, right? This EA bar. So this is very important here. Okay, when we are learning memory organization. So sorry, EA bar is basically external access or enable access. So you will notice there is a bar on top of it. EA bar means it is active low pin. When we are given zero or where we are basically grounding that pin, it is taking it as a complementary input. Complement is bar means complement. Okay, means it is considering as a higher input. When we are giving it a higher input, it is considering as a lower input, means bar, right? So when जब सब उल्टा है इधर, जब ये हम ग्राउंड कर देंगे ना, तो it will only consider external memory. Okay, it will only read data from external memory. Okay, when we are grounding that EA pin, it is going to read my external memory only. Okay, कंट्रोलर ऐसे कंसिडर करेगा कि ये बार इज जीरो, मतलब if we ground it is high, and I have to read data from external program memory. Okay, when EA is equal to 1, what it does is ये सिर्फ इंटरनल मेमोरी नहीं देखता है. ओके, इंटरनल मेमोरी तो देखेगा ही डेफिनेटली. 000H to 0FFFH. Okay, means it is, I guess, it comes around 4 KB if I'm not wrong. इंटरनल 4 KB ही होता है. ठीक है, सो 000H to 0FFFH ये तो कंसिडर करेगा जब ये 1 है. ठीक है, बट इसके बाद वो देखेगा क्या, 1000H to FFFH ये मेमोरी लोकेशंस वो कंटिन्यू करेगा. मतलब when EA is equal to 1, when we are connecting this to VCC, this pin, how our controller is behaving is, it will consider internal and external memory as one memory. Okay, so internal memory के addresses ये है 000H to 0FFH. Okay, and from 100000H to FFFFH external memory will be considered. Okay, ये रोम है. ठीक है, इसके एड्रेसिंग का तुम्हें इतना नॉलेज नहीं होगा तो भी चलेगा. ठीक है, बट व्हेन इट कम्स टू रैम or the data memory, you need to know the addresses. Okay, you need to at least know the basics. Okay, if not much part of it. Okay, so that's why. So is this thing clear till here? Like, this is our ROM. Okay, this is how it looks, and this is how it gets configured when coding. Are you understanding this?
Yes, sir.
Okay, okay. So suppose जब ये यूज कब होगी, I will tell you in practical application. Okay, so external memory जो है वो 64 KB की होती है, and internal जो है 4 KB की होती है. So very huge codes. Okay, very huge codes having lot of interrupts basically. Okay, क्योंकि इंटरप्ट सर्विस रूटीन में काफी ज्यादा जंप्स होते हैं. ठीक है, तो जब जंप वाली इंस्ट्रक्शन आती है तो वैसे भी वो ज्यादा मेमोरी खाती है. ओके, सपोज आई एम हैविंग सम लाइव साइट एप्लीकेशन, some medical related, okay, biomedical field related application. Suppose I am designing this machine uh, which is monitoring the vitals of the patients. Okay, and that system is designed using some sort of controller. Okay, I'm not commenting on which controller it is. I'm just giving you the example wherein, like, where such kind of application is applicable. So suppose one more thing before I start with that. Suppose you need extra uh, internal memory, okay, which is a ROM. You might be in need of extra RAM memory as well, and that is also possible. We can also interface external, some external memory, and we can use that as RAM as well. That's why this is very important. I mean, you can use it at any way you want. Okay, so yeah, so let's move on with our example. So the inpatient monitoring system, where the machine, okay, the system is monitoring the vitals of the patient, such as pulse, heart rate, BP. Okay, so uh, and O2 levels. Okay, let's say these four parameters we are monitoring. So every time the reading is taken from patient's body, it is somehow processed. There are some thresholds, there are some parameters that we might have set in our code to be considered as normal and to be considered as abnormal, and there are certain actions that are to be taken. So what happens in such systems is that even though one reading goes wrong, okay, by any of the reason or a genuine reason, and the calculation results in abnormal values, then it triggers an interrupt. Now interrupt, when interrupt is triggered, there are some jumping वाला instruction जो कि multiple bytes का होता है, so jumps भी multiple bytes से होंगे. And if there are more number of jumps in such code, okay, of course our code is gonna be lengthy, and that code, तुम भी सोचो ना, मतलब तुम पहले तो डेटा ले रहे हो एक फॉर्मेट में, ठीक है, जो भी फॉर्मेट, ऑफ कोर्स एनालॉग फॉर्म में होगा, तुम सेंसर से ले रहे हो तो उसको तुम कन्वर्ट करोगे, और ऐसे तुम्हारे पास चार है, मैंने सिर्फ चार बताया है, और भी पैरामीटर्स हो सकते हैं, टेम्प भी हो सकता है एक पांचवा पैरामीटर. सो you will convert all those five readings in CPU readable format, which is digital format. Then you'll process that, okay, then you will have some things stored inside your machine to be considered as normal and abnormal. That will take some memory. Then the processing part, the arithmetic calculation part, takes the maximum of it. Then decide decision part, then there are some function calls, there are so many things. So such codes cannot be written in such a compact memory, okay, it needs a lot of memory. That's why we need external memory to be there, okay. And which out of these two do you think is the most feasible combination, okay, which will give you more optimal use of both of the configuration, and like why, like uh, of course this EA1 is offering you more memory, and this I think is the best. What is according to you is best configuration?
So the combination of internal and external programming.
External, right? Because you can't go wrong here ना. इधर क्या होगा कि हम यही से रीड करना है, मतलब इंटरनल में मैंने कोड डाला है और इधर ही से रीड करना है, ओके, यू आर नॉट बॉदर्ड अबाउट योर एक्सटर्नल मेमोरी. अगर एक्सटर्नल मेमोरी है भी ना, तो उसका भी एक्स्ट्रा कोड आता है, ओके, यू विल सी दैट एक्सटर्नल मेमोरी का अलग कोड आता है, ओके, एंड दैट इज लेंथी बिकॉज उसका एड्रेस भी हमें मैनेज करने है ना, राइट. We have uh, port 0 and port 2 dedicated for addressing of the external memory. So ये थोड़ा complicated है anyways, okay. So we mostly try and avoid to use external memory, but certain cases are such that we can't avoid it. So we have to make use of external memory. And this is somehow we do that, okay. I'm not going into details of it because you don't need it. I don't want to complicate things unnecessary. As suppose future में हमें कोई चीज लगती है, then I'll explain you and then we'll go from there. So moving on with the program memory. So this is our RAM, okay. Are you able to relate to this now? Bank 0, 1, 2, and 3. So this suppose this is my complete RAM 00H to FFH, okay. This is my complete RAM. So I have divided it into two parts for your understanding purpose, okay. This is internal data memory and SFR space. So let's talk about each one of them individually. So first, let's talk about internal data memory. Now, this all is our internal data memory only, but this space is SFR space. SFR is special function register space. So from 80H to FFH, we have SFRs. Now, what are SFRs? One such example I already gave you about SFR, which is PSW, just program status word. Like I told you to select the register bank आई एम यूजिंग PSW. PSW का यूज सिर्फ सिलेक्टिंग अ रजिस्टर बैंक ही नहीं है. There are other things as well that PSW does, but so far let's stick to this application. Okay, because it is a 8-bit register, it has other 6 bits also for different applications. So we set the bits according to our application. So suppose PSW is one of the special function registers, so there are lot of such registers in here. Okay, and that is why this space is there for. So let's focus on internal data memory part. Now this part is again divided into two parts. Okay, and why two parts? I'll tell you. uh, okay, this is one. Okay, one. It's very difficult to write like this, guys. Okay, one FH. I just don't have my pen today. So this is 00H to 1FH. Okay, 00H to 1FH. We have our register banks. 00H to 1FH, and from 1FH to 7FH we have free memory locations. Okay, this is actual RAM, you can say. Okay, 1FH to 7FH. These registers or these memory locations are nothing but actual RAM locations. And 00H to 1, it is like our register banks. Okay, so 00 to 7H, I mean 00H to 707H is register bank 0. Okay, 08H to 0FH register bank 1, 10H to 17 is 2, and 18 to 1F is our
Excuse me, sir.
register bank. Yes.
So can you relate the address range with the internal? The address range is written as 00H to 07H, which is there. So how are we relating the address range with the diagram which is given on to the right?
Yeah, I'll tell you. So 00H to 77. So see, you see 00H over here. So 00H is register bank. I mean 00H to 007 means these are 8 locations, right? And these 8 locations are divided further into R0 to R7. Means this 00H means R0. You can consider R0 is there at 00H. Okay, then we
Okay.
have next location. So like this. Okay, you do not address this, these are not bit addressable. Okay, these are not bit addressable locations, so you can be least bothered about this. Bit addressable area is this one. Okay, the rest of the free space like RAM, like a computer RAM. So this is bit addressable. Suppose you got to work on these locations, you have to address it by particular bit. Okay, it will be there in next slide. So your question is particular about the first part of the internal data memory, which is 00H to 1FH. Okay, so this is divided into 4 register banks like this. Okay, and these are 8 locations. If you see 0 to 7 8, then 8 to 0F means 8 to 15, again 8, then 10 to 17 8, then 18 to 1FH means this is again 18 to next 15 locations. So this is how it is divided. Is this the doubt you had, or you wanted to ask something else?
No, no, it's fine. The basically this whatever the data which is given on to the left, it is related to the ROM, and it ranges from 00H to 1FH basically, and the down one is the RAM one, which is bit addressable.
Yeah, the thing is that see, all these registers. Okay, now don't get confused. In our ROM we don't have any register thing. In ROM we just have the locations. Okay, these two are different physically separated different memories. Okay, so locations also are different. And in ROM, we are not that concerned about these addresses. Okay, we are just storing our code over there using some techniques, And in RAM, we are concerned about it because we need it to manipulate the data in between our code. So that's why we need it basically. So it goes from 00H to FFH, and then further it is divided accordingly. Like bank 0 has some register, 1 has. So the reason behind telling you these locations is I told you earlier that we are we are just going to use, मतलब हम कोड में सीधा यूज करेंगे R0 या फिर R1 या फिर R7, whatever it is. Okay,
No.
मेमोरी लोकेशन कौन डिसाइड करेगा? रजिस्टर बैंक डिसाइड करेगी, which we will select using PSW register. First we will select the state of PSW register. Okay, in PSW I will say, PSW में मैं क्या करूंगा, I will select कि कौन सी बैंक मुझे चाहिए यूज करनी है. If I want to use 0, 1, 2 or 3. Okay, इन PSW का जो भी डेटा है, 1, I mean 0, 0. Okay, let me share my other screen to type. Basically the writing here is getting difficult for me. So just to explain you a bit further to this. So do you see my notepad window now?
Yes, sir.
Okay, so why I am writing it is, मैं ये बता रहा हूँ तुम्हें कि PSW में तुम क्या स्टोर करोगे जब तुम्हें कौन, मतलब पर्टिकुलर बैंक सिलेक्ट करनी है. ठीक है, सो PSW में मैंने 00 डाला तो इट विल सिलेक्ट रजिस्टर बैंक 0 which is concerned with these memory locations. Okay, okay, R0 to R7 हर बैंक में मिलेगा तुम्हें, बट इंटरनली मेमोरी लोकेशंस चेंज होंगे. ओके, एंड डिफरेंट प्लेसेस पे डेटा स्टोर होगा. दैट इज द मेन डिफरेंस हियर, एंड दिस इज रैम.
Okay.
सो या, सो सपोज अभी कंफ्यूजन और एक चीज का तुम्हें होगा बाद में जाकर, तो इसलिए मैं थोड़ा एलैबोरेट करूंगा. So PSW is again 8-bit, right? And I am saying my first two bits are concerned about this thing, concerned about register bank. So let's say R, मेरे को R0 select करनी है, RB0 मतलब register bank 0. But these are only first two bits. There are other 6 bits as also, okay, which you don't know and I don't know right now. So मैं इनको 0 consider कर रहा हूँ. 1, 2, 3, 4, 5, 6, 7 and 8. So ये वैल्यू मैं किस में स्टोर करूंगा? PSW में स्टोर करूंगा, जो कि है 0FH. ओके, एंड हेक्स में ना हमेशा हम H लिखेंगे इन द एंड, स्पेशली व्हेन यू आर स्टडीइंग कंट्रोलर्स. ये H लिखा जाएगा हमेशा. ठीक है, तो कंफ्यूज मत होना. ये H इज, it indicate it, the value is hexadecimal. Okay, for controllers. So 0FH I have moved, or 00H. Sorry, my bad. Okay, it is 00H, not FH. When would it be F? When all 4 bits over here would have been 1111, then it would have been F0FH. Okay, right now it's just 00H. So we moved this value to PSW, and because of that PSW में 00 है first 2 bits. कंट्रोलर knows कि अभी जो भी मैं कोड में यूज करूंगा, जैसे कि ये हो गया move R0 और R1 कॉमा 1FH, मेरे को ये वैल्यू इसमें डालनी है। तो अब मेरा कंट्रोल कर गया 1FH वैल्यू वो स्टोर करेगा R1 में, और कौन से वाले R1 में जाएगा, R0 के R1 में जाएगा वो डेटा, ठीक है। दिस इज द पॉइंट आई एम ट्राइंग टू मेक। उसका जो R1 है उसमें ये डेटा मिलेगा तुम्हें अभी 1FH आफ्टर एग्जीक्यूटिंग दिस इंस्ट्रक्शन। सपोज इधर इधर 0 1 किया तो ये बैंक सिलेक्ट होगी और इसमें डेटा जाएगा। सो डिपेंडिंग आवर नीड वी आर गोइंग टू मैनिपुलेट this status program status word register, and we are going to select particular register bank for particular applications. Okay. सो यहाँ पे और भी क्लियर होगा तुम लोगों को इंटरनल डेटा मेमोरी ऑर्गेनाइजेशन एंड मतलब ये पूरी तुम्हें रैम लोकेशन दिख रही है तुम्हें, ठीक है। आई टोल्ड यू कि मतलब वो जो पार्ट होता है ऊपर का वो ये है, ठीक है, जिसमें बिट एड्रेसेबल एरिया भी है एंड देयर इज रजिस्टर बैंक एरिया व्हिच इज 00h to 1FH। तो उधर वो इधर एलैबोरेट किया है उसको 00 to 1FH। ओके, 00 to 07 RB0, 08 to 0F RB1, then 10 to 17 R2, and 18 to 1F is R3. So this is how they are located. And एक चीज इधर important है, you just say R0 and R1. Okay, you are not bothered ki which location it is. Okay, but this bit addressable area, yeah, okay. So bit addressable area में होता क्या है ना कि these locations basically we address bits by bits. Okay, there is no option, only we have to, if we are using this, if we are consuming this in our code, then you have to address it bitwise. Okay, suppose let's say this slide. Okay, this is a register bank and this is a byte address 28. Okay, now this is a bit addressable area. So suppose from this location in 20H, okay, this is a byte address which I told you, like suppose this is R0, R0 का ये एड्रेस है, R0 में तुम, you are least concerned which location the data is going, but I want to show you how locations are designed inside of that memory. So suppose register 0 तुमने select किया R0, with the byte address of it is 20H. So inside of it again 0 1 2 3 4 5 6 7. Okay, every bit has an address. Okay, every bit has its own address, so it is that address. Okay, now R1 is located at 21H. This is the hexadecimal byte address of R1, and how it is further divided. So 0 to 7 हो गया. Now 8 9 10 11, 10 11 means A B C D E F 15. Okay, now again इधर 1 0 से start होगा, yeah, 1 0 1 1 1 2 1 3 1 4 1 5 1 6 1 7 1 8, क्या होगा। सो जब हमें 20 का बिट यूज करेंगे हम, वहां से हम 1A स्टार्ट होगा फिर से, करेक्ट। 1A 1B 1C 1D 1E 1F, ओके, लाइक दिस इट विल गो ऑन। सो सपोज इसको बिट एड्रेसेबल मतलब एक्सप्लेन करने के लिए मैं एनालॉजी एनालॉजी लिखी है इधर। सो द थिंग इज दैट सपोज you have to manipulate the bits in bit address from the bit addressable area। तो तुम सीधा इंस्ट्रक्शन लिख दोगे उस पे, ठीक है, लाइक लाइक clear, okay, clear 0C like this. You will directly target the location, okay, clear 1A, okay, ऐसे होगा वो assembly में, ठीक है. Even in C we have different set of instructions. You will get to know that, but so far remember this. Any doubt so far?
No, sir.
And I will be
Please.
referring it to the bank. Here we are referring it to the specific registries are there. No? And okay, every say there are four banks in that there are seven registers. Basically,
Each bank has 8 registers. 0 to 7 means 8.
eight registers, R0 to R7. And here
Yes.
bitwise we are referring it to it. And how do we separate between the banks, addressing between the banks? It is in
Addressing.
it is in
This is not.
continuity.
It is in continuity. See, 00 to 07 is bank 0, then 08 to 0F bank 1, like this. They are
Okay,
continuously located but
we can
still
target.
separated.
Okay, ठीक.
मतलब ये सीरीज ही है. अगर तुम लिखते जाओगे ना हेक्साडेसिमल नंबर, you will get to know ये सीरीज है. Okay, these are not distant apart from each other. This is a series. Okay.
Okay, okay. Thank you.
सो ये है हमारा मेमोरी ऑर्गेनाइजेशन. थोड़ा सा मतलब मैंने ये बहुत छाट के तुम्हें ये किया है, मतलब सामने रखा है. रोम का भी ना काफी कॉम्प्लिकेटेड है अगर तुम बुक्स पढ़ने जाओगे ना तो. बट दैट इज प्योर यू नो इलेक्ट्रॉनिक पॉइंट ऑफ व्यू. दिस इज अ बिट डिफरेंट. ओके, we are more focused on the application part of it. So let's learn till here. I mean, and जब भी हम कोड करेंगे तब कुछ एक्स्ट्रा लगेगा तो I'll clear that to you guys in advance. Okay, so ये प्लान है मेरा अभी के लिए. So anything you guys want to change, please let me know. So okay, what I wanted to tell you is okay. Anyways, मैंने वो I guess. Anyways, मेरे को जैसे याद आएगा I'll tell you. Mm, there was more to it, I guess. I'm not finding that. Anyways, are you guys still confused in stack pointer program counter analogy?
Yes, sir.
You still confused?
Yes, sir.
Okay, okay, cool. So, hmm. So let's talk about these two now. Okay, we have some time. The stack pointer and program counter. So ये दो अलग अलग चीजें हैं, ठीक है. Do not mix it. स्टैक पॉइंटर, अभी तुम्हें स्टैक एल्गोरिथम, स्टैक का तो चीज पता ही होगा. व्हाट इज स्टैक? कैन यू एक्सप्लेन मी? क्या क्या होता है स्टैक का ऑपरेशन? स्टैक है ना वो फर्स्ट इन लास्ट आउट है, राइट? डू यू अग्री विद दिस?
Sir.
हम्म. तो स्टैक का ये इतना ही ध्यान में रखो, अभी भूल जाओ स्टैक पॉइंटर जैसी चीज तुमने कोई पढ़ी, ठीक है. अभी प्रोग्राम काउंटर क्या है, सुनो मेरी बात। प्रोग्राम काउंटर में, प्रोग्राम काउंटर इज आल्सो ए रजिस्टर, ओके। उसमें क्या जाएंगे, लोकेशंस जाएंगे। किसके लोकेशन जाएगा, रोम का लोकेशन जाएगा जिधर अपना कोड स्टोर है। तो नेक्स्ट इंस्ट्रक्शन कहाँ पे है वो प्रोग्राम काउंटर बताएगा, किस लोकेशन पे पड़ी है नेक्स्ट इंस्ट्रक्शन, ठीक है। सीपीयू को पता नहीं है कि विच लोकेशन आई हैव टू गो एंड रीड द इंस्ट्रक्शन फ्रॉम। तो पता किसको है, प्रोग्राम काउंटर को। सीपीयू पूछेगा किसको, प्रोग्राम काउंटर को, मैं कहाँ से उठानी इंस्ट्रक्शन, ठीक है। ये बताएगा 00H को जा, उधर तुम्हें मिलेगा मेन फंक्शन, ओके। मेन फंक्शन में मेरी एग्जीक्यूट हो गई फर्स्ट इंस्ट्रक्शन, ओके। अब एग्जीक्यूशन में वो देखेगा कि कितने बाइट की इंस्ट्रक्शन है, अकॉर्डिंगली इंक्रीमेंट होगा वो, ठीक है। फर्स्ट इंस्ट्रक्शन हो गई एग्जीक्यूट, इंक्रीमेंट हो गया, सेकंड पे आ गया, ठीक है। देन थर्ड पे आ गया, देन फोर्थ पे आ गया, ऐसे इंक्रीमेंट होता रहता है, ठीक है। एक इंस्ट्रक्शन हो गई तो इंस्ट्रक्शन के साइज के अकॉर्डिंगली अपना प्रोग्राम काउंटर इंक्रीमेंट करेगा। उसने स्टार्ट कहाँ से किया है, इधर से किया है, ठीक है। स्टार्ट इधर से किया है और इंस्ट्रक्शन के साइजेस के अकॉर्डिंगली वो इंक्रीमेंट करते जा रहा है। एंड आर सीपीयू इज गेटिंग टू नो, ये क्या है, ठीक है। ये है मेमोरी लोकेशन, किस चीज का मेमोरी लोकेशन है ये, इस चीज का है ये है, ये है जो भी है, ठीक है। इंटरनली, सो फार लेट्स कंसीडर इंटरनल टू लेस कॉम्प्लिकेट आवर थिंग्स, ओके। तो इंटरनल रोम का लोकेशन है ये, ठीक है। इस लोकेशन में अपना कोड पड़ा है, तो वो कोड वो पढ़ रहा है, ठीक है। एंड अकॉर्डिंग टू द इंस्ट्रक्शन इट इज इंक्रीमेंटिंग बाय इंस्ट्रक्शन साइज। सपोज सपोज अपनी इंस्ट्रक्शन साइज लंबी है, इंस्ट्रक्शन साइज ज्यादा है, तो होगा क्या, अकॉर्डिंग टू दैट साइज इट विल इंक्रीमेंट। 05 को जा सकता है, 06 को जा सकता है, ओके। आगे समझ में, सपोज मेरा कोड ऐसे प्रोग्रेस हो रहा है, ठीक है। ये मेन है, मैंने कुछ इनिशियलाइजेशन किया है इधर, ठीक है। एंड एट दिस पॉइंट मेरा एक फंक्शन कॉल है, ठीक है। फंक्शन गेट सेंसर डेटा, सपोज ये फंक्शन इधर लिखा है, ठीक है। या फंक्शन कॉल किया है मैंने, बेसिकली लेट्स टेक इट एज फंक्शन कॉल ओनली, ओके। तो जैसे ही फंक्शन कॉल आ गया, फंक्शन कॉल, ठीक है। अभी फंक्शन कॉल आ गया तो होगा क्या कि फंक्शन कॉल आ गया तो हाउ विल आवर प्रोग्राम काउंटर इंक्रीमेंट, फंक्शन है ये तो, ठीक है। इट हैज टू जंप टू द फंक्शन का लोकेशन एंड read data from there and then go come back here. So होता क्या है, तो ये जो 05H है ना, ये तुम्हारा इसमें चला जाएगा, में से, ठीक है। इधर आ गया ये, ठीक है। स्टैक में चला गया कि लास्ट इंस्ट्रक्शन मैंने यहाँ से एग्जीक्यूट की थी, इधर के बाद मेरे को देखना है फिर से क्या है। तो प्रोग्राम काउंटर अभी सीपीयू फंक्शन एग्जीक्यूट करके वापस किसको पूछेगा, स्टैक को, कि मैंने लास्ट कहाँ पे लिखी थी इंस्ट्रक्शन, 05H पे। 05H के बाद क्या है, वो इंस्ट्रक्शन एग्जीक्यूट होगी। तो दिस इज बेसिक एनोलॉजी, ओके। अभी ज्यादा कॉम्प्लिकेट नहीं करेंगे हम इस चीज को, बस इतना ध्यान में रखो, प्रोग्राम काउंटर में जो इंस्ट्रक्शंस हमें पढ़नी है, सीपीयू को जो इंस्ट्रक्शंस लोड करनी है वो प्रोग्राम काउंटर से लोड होगी। स्टैक पॉइंटर मतलब जब भी कोड में कोई ऑब्स्टेकल आएगा उसका लोकेशन स्टैक पॉइंटर में जाएगा, ठीक है। उसका लोकेशन स्टैक पॉइंटर में जाएगा और प्रोग्राम काउंटर वो स्टैक पॉइंटर से रीड करेगा, क्योंकि प्रोग्राम काउंटर में अभी क्या होगा, प्रोग्राम काउंटर हैज डिफरेंट रिस्पॉन्सिबिलिटीज नाउ। प्रोग्राम काउंटर में कोई भी और लोकेशन अभी लोड होने वाला है, ओके, anything it could be, okay, don't go by this location literally, but it could be anything. So फंक्शन कॉल होने के बाद लास्ट लोकेशन क्या है याद होना चाहिए, लास्ट लोकेशन पता होना चाहिए, इसलिए स्टैक पॉइंटर का यूज होता है। Not only in function call, but interrupt service routine is also another function written somewhere, right? So that also gets called. So what is that call? Where is that call getting stored? That is getting stored in stack pointer. Okay, it is pointing stack pointer का almost मतलब always ना top point out होता है, तो first in last out है ये, sorry first in first out है ये, sorry my bad, okay, first in फर्स्ट इन लास्ट आउट, राइट, नो फर्स्ट इन, जो सबसे पहले अंदर गया वो लास्ट में बाहर निकलेगा। अभी इसके बाद और कोई फंक्शन आया सपोज, और फंक्शन आया कोई, ठीक है, फंक्शन कन्वर्ट डेटा, ओके, इसके और भी कुछ एड्रेसेस होंगे। हम्म तो अगेन अगेन अभी ये इधर का जो लास्ट एड्रेस है वो इस पे स्टोर हो गया था अगेन, ठीक है, इसके टॉप पे फर्स्ट इन लास्ट आउट है ये, ठीक है। तो एक एक लोकेशन वो बाहर निकालते जाएगा, पुश एंड पॉप यूज होता है इसमें स्टैक में। तो एड्रेस जब पुश करना है तब पुश, जब पॉप करना है तब पॉप। तो होगा क्या कि जब हमें नॉर्मल एग्जीक्यूशन स्टार्ट करना है तो वी नीड टू गेट बैक टू दीज लोकेशंस, राइट। ये कहाँ पर स्टोर्ड है, इधर स्टोर्ड है ऑलरेडी, तो दिस इज व्हाई द प्रो स्टैक पॉइंटर इज इम्पोर्टेंट। थोड़ा सा आया समझ में या और कंफ्यूज हो गए?
सर
हम्म
मतलब सपोज अगर मतलब प्रोग्राम काउंटर जो इंस्ट्रक्शंस है तो उनकी लोकेशंस ऐसे मतलब 0001 ऐसी रहती है कि रैंडम रहती है।
मैं बताता हूँ, ठीक है। तो ये लोकेशन कौन सी रहेगी, अपने रोम की लोकेशन रहेगी, ठीक है। सपोज माय रोम इज गोइंग फ्रॉम 00h टू FFH, ठीक है। तो प्रोग्राम काउंटर को एक लोकेशन पता होती है बाय डिफॉल्ट 00h, उसके दिमाग में फिक्स है कि यही लोकेशन पे मेन स्टोर्ड है, ठीक है। तो हमें जब हम सिलेक्ट करेंगे ना, हम जब कोड करेंगे, लिखेंगे कोड, एडिट करेंगे, तो उस टूल में इट आस्क्स कि विच कंट्रोलर यू आर गोइंग टू यूज। सो आई एम सिलेक्टिंग 89C51। सो 89C51 में तो वो क्यों पूछता है कि उसको पता है कि वो स्टैक पॉइंटर में, सॉरी प्रोग्राम काउंटर में कौन सा लोकेशन पे मेन, मतलब प्रोग्राम काउंटर को मेरे पता है कि 00h को मेन स्टोर्ड है, तो मेरे मेरा कोड उसी लोकेशन पे स्टोर होना चाहिए। इट मेक श्योर दैट, ओके, इट मेक श्योर कि मेरा कोड उसी लोकेशन पे स्टोर हो, एटलीस्ट मेन फंक्शन, फर्स्ट इंस्ट्रक्शन उसको मिल जाए बस, बाकी का वो संभाल लेगा, फंक्शन कॉल्स वो स्टैक पॉइंटर के हेल्प से संभाल लेगा, ये चीज होती है। सो अपनी जो रोम है उसमें ये सारे लोकेशंस फिक्स्ड है, ठीक है। We don't know these locations, we are not going to play with these locations, program counter is going to play with these locations. And why you need to understand this is because you need to understand how our controller starts, okay, you need to understand this the booting process, okay, boot process और डिटेल में हम नेक्स्ट सेमेस्टर में सीखेंगे जब तुम एम्बेडेड सिस्टम सिक्योरिटी सीखोगे, क्योंकि हमें सीखना है सिक्योर बूट इज माय अल्टीमेट एम, ओके। तुम्हें सिक्योर बूट समझ में है, उसके लिए बूट प्रोसेस समझ में है, इसलिए ये सब चल रहा है, ठीक है। तो ये चीज है। अब कुछ डाउट है और तुम्हारे, मतलब चीज तो बेसिकली ये ध्यान में रखो कि प्रोग्राम काउंटर मेरा इंस्ट्रक्शन का एड्रेस दिखा रहा है, ठीक है, इंस्ट्रक्शन कहाँ पे स्टोर्ड है उसका एड्रेस दिखा रहा है विद द हेल्प ऑफ स्टैक पॉइंटर। अगर कोई इंटरप्ट आता है, अगर कोई फंक्शन कॉल आता है, तो स्टैक पॉइंटर याद रख रहा है मेरा इंस्ट्रक्शन का, मतलब लास्ट कहाँ से एग्जीक्यूशन स्टार्ट हुआ था, ओके, ये चीज है। और कुछ डाउट है तुम्हारे?
नो
Of
सर।
course you have doubts. You can reach out to anyone, can reach out to me any point in time. Okay, I will be happy to help you. Okay, कभी भी तुम्हें कुछ भी डाउट होगा ना, so just reach out to me on WhatsApp or on my phone number. Basically, I'll be happy to help. We can connect further and we can resolve your queries. Let me stop recording for now.